So let us derive an expression for the electric potential at a point around an electric dipole. Suppose you have an electric dipole. An electric dipole means two equal and opposite charges, let's say q and minus q, separated by a small distance. See, this plus q and minus q charges separated by a distance 2a. We usually take the distance between the charges as 2a, so that the distance from the center of the dipole to one of the charges is a and to the other charge is also a. Let's take this point as a. Let's take this point as b. Let there be a point b in here, and we are interested in finding the electric potential due to this dipole at the point b. For that, let us join these two, that is the point P and the center of the dipole. Also, the line join AP and BP. Clear? Let us assume this angle be theta, so that this angle will be 180 minus theta because they form a linear pair. Let's call this distance OP equal to R, and let's call this R1 as, sorry, AP as R1 and PB as R2. Now we have electric potential at the point P, electric potential at the point P. Let's write electric potential at P. Let's say that as electric potential at P is the electric potential due to this plus Q charge at P, that is V plus Q, plus electric potential due to this minus Q charge at P, that is V of minus Q. Since the electric potential is a scalar quantity, you simply have to add these two. That is Vp will be, but you know the expression for electric potential, it is 1 by 4 pi epsilon 0 charge divided by distance. Distance will be R1 plus 1 by 4 pi epsilon 0. Electric potential due to minus Q will be minus Q divided by the distance is R2. And you can write this as potential at P is equal to, you can take this Q by 4 pi epsilon 0 outside, Q by 4 pi epsilon 0, 1 divided by R1 minus 1 divided by R2. Let's call this as equation number 1. Let me write it in here. Let me erase this because you already know that distance is 2a. Because we have to take this equation later. So Vp will be Q divided by 4 pi epsilon 0 times 1 by R1 minus 1 by R2. Let's take that as equation number 1. Now we need to find an expression for 1 by R1 and 1 by R2. For that, let us take the law of cosines. For that, consider the triangle AOP. Consider triangle AOP. We have the side opposite to angle theta is R1. So R1 square is equal to, according to law of cosines, the adjacent sides, square of the adjacent sides, R square plus A square minus 2AR cos theta. Now R1 square is equal to, you can take this R square outside, R square into 1 plus, here there is no R square, so you can write like this, A square by R square minus 2AR cos theta divided by R square. So that if you multiply R square with whole terms, you will get this equation, the equation above. See, this term, we know R is very much greater than A. If you compare the distance A and R, r is very much greater than a. So that a by r is approximately 0. So a square by r square is also 0. That is a square by r square equal to 0. So you can neglect this equation. Sorry, this term. So r1 square will be r square into 1 plus, sorry, 1 minus, you can cancel one of the r, that is 2a cos theta divided by r. Now r1 will be, you can write this as, if you take the square to the right, it will be root of r square into 1 minus 2a cos theta divided by r. So this equation will be r1 is equal to r square, when root it come out of the root, it will be r. You can write this as 1 minus 2a cos theta divided by r whole raised to, root can be also written as 1 by 2, power 1 by 2. Now if you take the reciprocal on both the sides, that is 1 by r1 is equal to, if you take the reciprocal on the left side, you have to take that also on the right side. That is 1 by r into 1 minus 2a cos theta divided by r whole raised to 1 by 2. So 1 by r1 is equal to 1 by r into, you can take this term to the numerator, so that it will be 1 minus 2a cos theta divided by r whole raised to minus 1 by 2. The power reverses. Sorry, the sign of the power changes. You know this term 2a by cos theta. Let me erase this. You know this term 2a cos theta divided by r is always less than 1, because r is very much greater than a. So 1 minus x raised to n is equal to 1 minus nx if x very much or x less than 1. We have this binomial equation. So the power will come in here as a coefficient. So 1 by r1 is equal to 1 by r into 1 minus, here it is minus 1 by 2 into 2a cos theta divided by r. Clear? Let me erase this. That is 1 by r1 is equal to 1 by r into minus and minus will get cancelled, 1 plus 2 and 2 you can remove, so 1 plus a cos theta divided by r. So 1 by r1 is equal to, let me write here, 1 by r1 is equal to, you can multiply, you can take this 1 by r to the brackets. So 1 by r plus a cos theta divided by r into r square. Let's call that as equation number 2. Now similarly, you have to find the equation of r2. That is, if you take this triangle, consider triangle BOP. Again you can use the law of cosines. The angle, the side opposite to r2 is 181. The angle opposite to r2 is 180 minus theta. So that r2 square will be, adjacent sides of 180 minus theta are r square plus a square minus 2ar cos, here angle is 180 minus theta. This is just the law of cosines. Clear? That is r2 square is equal to r square plus a square minus 2ar. See, cos 180 minus theta is actually minus cos theta. So that this minus and minus will get cancelled. So r2 square will be r square plus a square plus 2ar cos theta. Therefore, r2 square is equal to, just do the same procedures before. First you have to take r square, so that it will be 1 plus a square by r square plus 2ar cos theta divided by r square. This will be 0 because a by r is less, is very much, a is very much less than r, so you can neglect this term. Also you can cancel this term, one of the r's. So r2 square will be r square into 1 plus 2a cos theta divided by r. Now you can take the root on both sides, that is r2 will be root of r square into 1 plus 2a cos theta divided by r. So this will be r2 is equal to r. See, root of 1 plus 2a cos theta by r can be written as 1 plus 2a cos theta divided by r whole raised to 1 by 2. And if you take the reciprocal in here, 1 by r2 will be 1 by r into 1 plus 2a cos theta divided by r whole raised to 1 by 2. Now you can take this 1 plus 2a cos theta by r term to the numerator, so that 1 by r2 will be 1 by r into 1 plus 2a cos theta divided by r whole raised to the power, the sign of the power changes, minus 1 by 2. Again this minus 1 by 2 will come to the coefficient using binomial expression. Therefore, Therefore, 1 by r2 is equal to 1 by r into 1. This is equal to plus minus 1 by 2 into 2a cos theta divided by r. You can cancel this 2, so that 1 by r2 is equal to 1 by r into 1 minus a cos theta divided by r. Also, you can take this 1 by r to the inside of the bracket, so that you will get 1 by r2 is equal to 1 into 1 by r is 1 by r minus a cos theta divided by r square. Clear? Call this as equation number 3. Now you got 1 by r1 and 1 by r2, and you can substitute that in the equation 1. You can substitute these two values in the equation 1, so that potential at P will be Q divided by 4 pi epsilon 0 times, instead of 1 by r you can write 1 by r plus a cos theta divided by r square. Now this minus you have to put a bracket. Let me erase this. One by r2 is 1 by r minus a cos theta divided by r square. Clear? On simplifying this you will get Vp equal to Q by 4 pi epsilon 0 1 by r plus a cos theta by r square minus 1 by r, minus of minus will get plus A cos theta divided by r square. You can cancel this one, and the final expression will be Vp is equal to Q into A cos theta plus A cos theta. Write this as 4 pi epsilon 0 2a cos theta divided by r square. Clear? Now, Vp can also be written as potential at P. Vp is equal to, this can be written as 1 by 4 pi epsilon 0 Q into 2a cos theta divided by r square. But you know, Q into 2a for a dipole, for any dipole, one of the, this is minus q and this is plus q, and the distance between them is 2a. One of the charge into distance between the charge is dipole moment. That is, dipole moment P is equal to q into 2a. So the expression turns out to be Vp equal to 1 by 4 pi epsilon 0 P cos theta divided by r square. Clear? This is the expression for potential at any point around a dipole. Now what will be the potential at a point on the axial line and the equatorial line? Let's take that also. Now we have derived the expression for electric potential due to at any point due to an electric dipole. We got that as this Vp equal to this one. Now we need to find what is the electric potential at a point on the axial line. So what is this axial line? Axial line means any line passing through AB. So at any point along the line through AB, suppose if I take a line through AB like this, at any point on this line, the point will be axial point. Suppose if I take a point P in here, suppose this point P is in here. So what does that mean? That means if you rotate this OP towards the left or in the counterclockwise, anti-clockwise direction, you will get the point P in here, which means theta is equal to 0 degree. Or one more case, if you rotate the P towards the right, suppose P is in here, that also is axial line, but in that case, in this case you are rotating in this direction, OP. Here you are rotating in this direction, in the clockwise direction or towards the right. In that case, second case, theta will be 180, which means theta can take the value 0 or 180 for an axial point. So substituting in here, you will get Vp equal to 1 by 4 pi epsilon 0. First, take the value theta equal to 0. Write P cos 0 divided by r square. We have taken theta equal to 0 degree. So Vp will be 1 by 4 pi epsilon 0 P divided by r square, since cos 0 is equal to 1. Now if theta is equal to 180, then we have Vp is equal to 1 by 4 pi epsilon 0 P cos 180 degree divided by r square. But you know cos 180 is equal to minus 1. Here we put theta is equal to 180 degree. Then Vp will be cos 180 equal to minus 1. So minus 1 by 4 pi epsilon 0 P divided by r square. Let's call that as equation number 3. So as a result of that is at axial point, at a point on the axial line, the potential will be 1 by plus or minus, you can write this as Vp, or you can write this as V axial will be plus or minus 1 by 4 pi epsilon 0 P divided by r square. So this is the expression for electric potential at a point on the axial line. Now, what about a point on the equatorial line? Let's take that case. Case B, at a point on the equatorial line. See, equatorial line means any line passing through the center of the dipole and perpendicular to its length. That is this line. Clear? Any line passing through the center of the dipole and perpendicular to the length of the dipole. So the angle, you can clearly see that the angle theta will be 90 degree. No doubt theta is equal to 90 degree. Okay, and if the point is above the dipole, theta will be 90 degree, and if it is below the dipole, the angle will be, if you rotate this much angle, theta will be 270 degree. Okay. In both the cases, Vp is equal to 1 by 4 pi epsilon 0 P cos 90 divided by r square is equal to 0. Also, cos 90 is equal to 0. So, Vp is equal to 0. If it is 270, that also 1 by 4 pi epsilon 0 P cos 270 divided by 270 degree by r square. That also is 0. So, V equatorial is equal to 0, which means there is no electric potential on the equatorial line. Clear?